What is temperature in large language models? You have probably heard that you can make an AI more creative or more precise by adjusting something called temperature. But what exactly is it doing under the hood? Temperature is not about making the AI smarter or dumber. It is about controlling how the model samples from its own probability distribution. At every single generation step, set it to 0 and the model always picks the single most likely word. Turn it up and lower probability words get a real shot, producing surprising, varied, sometimes brilliant, sometimes chaotic output. Today on Neural Monk, we go deep on temperature. The math, the intuition, the practical settings, and the mistakes to avoid. By the end of this video you will know exactly which temperature to use for every task you throw at a language model. Before we can understand temperature, we need to understand how a language model picks its next word. Every generation step has 3 stages. First, the model produces logits. These are raw, unnormalized scores, one for every token in the model's vocabulary. A vocabulary might contain 50,000 tokens or more. Each logit represents how strongly the model believes the token should come next. Second, the softmax function converts these logits into a valid probability distribution. Every token gets a probability between 0 and 1. All probabilities sum to exactly 1. Third, the model samples one token from this distribution. That sampled token becomes the next word in the output. Temperature operates in this third step. It reshapes the probability distribution before sampling happens. The logits are the raw signal. Softmax converts them to probabilities. Temperature controls how that conversion happens. Here is the temperature formula. The probability of token I equals exp of z underscore I divided by t. Divided by the sum over all j of exp of z underscore j divided by t. The key operation is simple: divide every logit by t before you apply softmax. When t is less than 1, you are dividing by a small number. That amplifies the differences between logits. The strongest token wins by an even bigger margin. The distribution becomes sharper, more concentrated on the top tokens. When t is greater than 1, you are dividing by a large number. That compresses the differences between logits. Every token gets a more equal share of probability, the distribution flattens. When t equals 1, you divide every logit by 1, nothing changes. You get the raw model distribution exactly as the model learned it. This is why temperature equals 1 is always the neutral default. Low temperature, from 0 to about 0.5, makes the model focused and precise. At temperature equals 0, you get what is called greedy decoding. The model always picks the single highest probability token. The output is fully deterministic, the same prompt always gives the same result. At temperature 0.2, the top token still wins around 98% of the time. The model is nearly deterministic, but allows occasional variation on less confident choices. Look at the bar charts in this scene. At t equals 0.2, the token blue has almost all the probability mass. At t equals 0.5, it still dominates, but gray and clear get a small share. At t equals 1, the distribution spreads out: 61% for blue, 23% for gray. Low temperature is your best friend for code generation, factual question answering, data extraction, arithmetic, and any task where reproducibility matters more than variety. Same prompt, same result, every time. High temperature, from 1.0 upward, unlocks creativity and diversity. When you increase t above 1, the logits get divided by a number greater than 1. This compresses their differences and flattens the distribution. Tokens that normally had a small chance now get a real shot at being selected. Look at the 3 outputs from the same prompt. Write a sentence about the moon. At t equals 0.2, you almost always get the same factual sentence. The moon is a natural satellite orbiting Earth at 384,000 kilometers. At t equals 1.0, you get natural, descriptive prose that varies a little each run. At t equals 1.8, the model starts choosing unusual, poetic words. Sometimes beautiful, sometimes strange. The moon blinked at Jupiter, whispering tidal confessions to the reef. That sentence could only come from a high temperature setting. But there is a risk zone. Beyond 1.5, outputs start to degrade: incoherent sentences, wrong grammar, strange hallucinations. At 2.0, the distribution is nearly uniform and the model picks almost at random. Temperature is not the only parameter that controls output diversity. It has two close relatives, top P and top K. Let us understand how they differ. Temperature reshapes the entire probability distribution by dividing all logits by T. It is a soft, global, continuous control. Top P, also called nucleus sampling, works differently. After softmax, it keeps only the smallest set of tokens whose cumulative probability reaches P, and discards everything else. If P equals 0.9, you sample only from tokens that together account for 90% of the probability mass. Top K is even simpler. It just hard limits the candidate set to the top K tokens. If K equals 50, you sample from the 50 highest probability tokens only. The most important practical rule: temperature and top P are complementary, not redundant. Temperature reshapes. Top P trims the dangerous tail. The most common production recipe across OpenAI, Anthropic, and Google is temperature around 0.7 combined with top P of 0.9. Use them together. Avoid adjusting both at the same time when debugging. Let me give you a practical quick reference guide for temperature by task type. For code generation and debugging, use T between 0 and 0.2. You want the same correct answer every run. Creativity is actively harmful here. For arithmetic and maths problems, use T of 0 to 0.1. There is only one correct answer and you want it every time. For factual question answering and summarization, T between 0.2 and 0.5 works well. Accurate, reliable, slightly varied phrasing. For conversational chat assistance, T between 0.7 and 1.0. Feels natural. Engaging but not random. For creative writing and storytelling, T between 1 and 1.3. Gives expressive, varied, imaginative output. For brainstorming and idea generation, T between 1.2 and 1.5. Produces diverse and genuinely surprising suggestions. The golden rule: start at T equals 1.0 and tune from there. Go down for precision. Go up for creativity. The temperature parameter is named the same way in every major API. OpenAI, Anthropic, and Google all use the key temperature. Every major AI product exposes temperature through their API. GPT-4 and GPT-4o from OpenAI default to 1.0 with a range of 0 to 2. For coding tasks, OpenAI recommends 0 to 0.2. For chat and creative tasks, they suggest 0.7 to 1.0. Claude from Anthropic also defaults to 1.0. But the API caps the maximum at 1.0, unlike OpenAI, which goes to 2. Anthropic's extended thinking mode always uses temperature 1 internally. Gemini from Google defaults to 1.0 with a range up to 2. The faster Flash models often run at 0 for maximum speed and determinism. Llama 3 from Meta and Mistral default to 0.6. Giving open source users full control with no hidden constraints. The code example in this scene shows exactly how to set temperature in the Anthropic API. 1 parameter. 1 line. Temperature equals 0.7. That is all it takes to control the entire sampling behavior of the model. Let me walk you through the 5 most common temperature mistakes that developers make when shipping production LLM applications. Mistake 1: using high temperature for factual tasks. Setting T to 1.5 for a medical question answering system will give you creative but wrong answers. The fix: use T between 0 and 0.2 for anything requiring accuracy. Mistake 2: using low temperature for brainstorming. T equals 0.1 kills all variety, you get the same idea every time. The fix: use T between 1 and 1.3 for idea generation. Mistake 3: using high temperature without a top P guard. High T can push probability mass into very strange tokens. Add top P equals 0.9 as a safety net to clip the tail. Mistake 4: not setting a fixed seed during testing. Without a seed, any T above 0 gives different results every run, making it impossible to debug output quality issues. Mistake 5: changing temperature mid-conversation. Set it once for the session and leave it. And remember, temperature does not affect what the model knows. It only affects how varied its expression of that knowledge is. Let us bring it all together. Temperature in large language models is the parameter that controls how the model samples from its own probability distribution at every generation step. The model produces logits raw scores for every token in its vocabulary. Softmax converts them to probabilities. Temperature divides all logits by T before softmax is applied. Low temperature, below 1, sharpens the distribution. The most likely token wins by an even larger margin. Use this for code, facts, maths, and data extraction. High temperature, above 1, flattens the distribution. Lower probability tokens get real chances. Use this for creative writing, brainstorming, and storytelling. Temperature equals 1 preserves the raw model distribution exactly. It is the neutral, balanced default. Top P clips the tail after temperature shapes the distribution. Use them together, not separately. Every major AI API exposes temperature with the same name and similar defaults. The golden rule: T equals 0 for code, T equals 0.7 for chat, T equals 1.2 for creativity. Temperature is the single knob that separates the robot from the poet. Next in the All About LLM series, Top P and Top K sampling, a deep dive into the companion parameters. Like and subscribe to Neural Monk for weekly explainers on AI and machine learning.